Alright, in our last section, chapter 9, we're going to look at matched pairs tests for means. So for their second semester project in AP Stats, Libby and Catherine decided to investigate which line was faster in the supermarket, the express lane or the regular lane. To collect their data, they randomly selected 15 times during a week, went to the same store, bought the same item. However, one of them used the express lane and the other one used a regular lane. To decide which lane each of them would use, they flipped a coin. If it was heads, Libby used the express lane and Catherine used the regular. If it was tails, Libby used regular and Catherine used express. They entered their randomly assigned lanes at the same time, and each recorded the time in seconds it took them to complete the transaction. Carry out a test to see if there is convincing evidence that the express lane is faster. Alright, so here's the deal. We have two sets of data, right? Express lane and regular lane. Because we're looking at the time difference between express and regular, right? We really don't care about the individual times. We want to know what's the difference between the two. So when there's that possibility that you need just the difference, you're just looking at the difference between trial 1 and trial 2, that becomes a matched pair test. All right? Now, so what does that mean? That means in list 1, I'm going to type all this data. In list 2, I'm typing all this data. List 3 in my calculator, I'm going to tell it to take list 2 and subtract list 1. So that's regular lane time minus express lane time, right? So here are the differences. Now, that's what I'm going for. Really, I'm running a test on the differences between the two. These are matched because they were on, each line is an individual day, right? So if each row of data is traced back to the same unit, could be a day, it could be a person, or any of that, that makes it a matched pair test. So always check when you have two sets of data, should it be matched pair or not? Because if it is matched pair, you're just doing a one sample t-test. That's all you're doing, all right? So let's look at this. So remember the question says to carry out a test to see if there's convincing evidence that the express lane is faster. Well, how do we know if it's faster? Well, we did regular minus express lane, right? If the express lane is faster, that means that we're going to have a positive difference because we did regular minus express, right? If express is lower than regular, then we should have a positive difference. So some of ours are positive, some of them are negative. So do we have enough evidence to say that it really is faster to use the express lane? So we're going to run the test on these numbers right here. So let's state our hypotheses, all right? Now, test that the mean of the differences, notice it's the mean of D for differences, versus the mean that there is no difference here, that there is a difference is greater than 0, meaning a positive difference. That would make the express lane faster. So that's how I determined positive. At the alpha equals 0.05 level, where mu of D, that's not a 0, that's a D, equals the true mean difference, and I designate how I subtracted regular minus express lane, in time required in the lanes. Okay? So use mu of D and make sure you define what is it? What difference are you looking at? Right? And should the differences be negative or positive? In this case, we want a positive difference. So let's keep going. Alright, so now we're on our plan step. We want to perform a paired t-test. Notice I didn't say one sample t-test, I said paired. If the conditions are met, okay, random times at the store and they were randomly assigned a line. Remember they flipped the coin to decide which line they were in? Both are important. Random times and random assignment. The selected times out of infinite possibilities, right? So the differences should be independent, really. How many times did they do it? 15. Could they have done it 150 times or 1,500 times? Of course. So the differences really are independent. It doesn't matter. Now our sample is 15, which is less than 30, and we don't know anything about the population of this. So we are relegated to making a dot plot and looking at the shape of our sample. So here's the shape of our sample. Okay, it's nothing remarkable. It could be almost normal, really. So what does this tell us? It tells us the sample data has no strong skewness or outliers. So it's reasonable to use T procedures because the population appears to be normal. It's not the sample that appears to be normal. That's not what this is telling us. It's telling us that the population appears to be normal if there's no skewness, strong skewness, or outliers. All right, let's use our do step. Let's do this. So we've done this in our calculator. Remember, in list 3, we have our differences. So I can use my calculator. I can go to stat test number 2, which is t-test. I can choose data. My null value is 0. I actually need to make my list 3. Mine happened to be in list 1 in my calculator, but it's a long story. So anyway, with the correct data, you would, if list 3 was where you put your differences, that's what you would put there. And then I want the greater than inequality because that's what I have my alternative hypothesis. So when I hit calculate, I get this output. There's my t-value, there's my p-value, x-bar, and s. All the things I need to show my work in my formula. So I would then show my t-value formula. So there's x-bar minus 0, that's the null value. Standard deviation divided by the square root of my sample size gives me a t-value of 1.97. Great, awesome. Now, then I draw my curve, and here's 1.97, and I'm shading to the right because it's a right-tailed test. It's a greater than. And it gives me the p-value right there, 0.0346. You could round that to 0.035. It's close enough, all right? Now, that value helps me make my conclusion. All right, so since 0.034 is less than our alpha, we reject the null. There is convincing evidence that the express lane is faster. That's what our alternative was asking, right? Is it faster? We have enough evidence to say that it is. So with a matched pair test, you have you start with 2 sets of data, you find the differences, and then you run a t-test on those differences to find out if you have convincing evidence of whatever they're asking you for.